All right, good morning and welcome to our first session on this course. Again, I welcome you to the second year of study where we are now proper running of civil engineering starts. As you have seen in first year, it was more of the what we call the A level for those people who can attest to that. You are learning more of mathematics, more of physics, and so on and so forth. But here now we start learning the courses in civil engineering. So allow me to switch this. I was just monitoring. I was also buying time so that we can have more connection. I know this is the first of its type with you guys. So I know maybe some of you have not had this encounter of online lectures, but I know in first year, of course, you came during COVID. So basically you have had experience with online learning. And there are some lessons that we learned from the COVID that we can use online to even have more interactive learning. So that's why we are planning to have this kind of learning in terms of hybrid, physical and online. As you can see from your timetable, the second session, for example, on Thursday, it's indicated to be allocated or no lecture hall. So you see with the learning, we are unlimited. We can have as big class as we want without wondering where we are going to get the venue. All right, before I start, just to set some house rules in order, it's always good to acknowledge that you have come to the second year by the grace of God. So I'd like to start with a brief word of prayer because it's my first encounter with you, and also wishing you well in your studies in second year and also going as you train to be an engineer. Our God and our Father, this word of morning, we are grateful for granting us a chance, mighty Lord, to start this course. Thank you for this class, Almighty God, my first encounter with them. And I pray and hope, Almighty God, that I'll be able to impart proper knowledge and understanding unto them, O God. As they train to be engineers, O God, I pray that you may increase them in wisdom, in understanding and knowledge, O God, in the mighty name of Jesus. We pray for a good start, and even as we head to the median and the end of the semester, guide and direct us. In the mighty name of Jesus Christ, we pray and give thanks. All right, thank you. First house order, I want to remove my video because sometimes it overlaps some text as I share. So when you see me going off, don't worry why. It's because I want to make the PowerPoint to be full screen, right? Number two, you register your attendance by typing your name, your official name and your registration number so that we can be able to take the attendance of this lecture. Number three is that today is just a short introduction of just sharing what we'll be doing in this course. First is that the course is called Civil Engineering Materials CC 2206, but this is just a code for JQuat. So globally, as you go to maybe the library to get for textbooks, you know, you might be limited if you start looking for textbook only written civil engineering materials. This course in itself is about concrete technology or concrete and masonry technology. And it's basically an introduction, but a very, very crucial and key research area because I believe even in our 5 years course, you're not going to learn again about the technology, the concrete, but you are supposed to become materials engineer, to know about quality controls of concrete, to be able to go to site and ascertain the quality that have been designed for, that have been implemented. So I hope that you're going to take this with all the care on that, all the seriousness that it deserves, so that you come out with something. Number four, about the housekeeping rules is that this is more of it's theoretical, but a big chunk of it is practical aspect. There are a lot of tests. Now, the challenge that we have with this is that our groups are large. We have about over 100 plus 20. I believe class rep, you can confirm that. I believe we should be more than 120 or 130. So sometimes you find people, they go to the lab, they just joyride because you not be doing it individually, you're doing it as a group. But I urge you, make sure that you don't just sail through, right? And come out when you are in fifth year, when you're doing your projects. That's when you realize that this guy doesn't know how to conduct basic material tests. So utilize the time that you have, utilize the resources that we have. Most of the practicals will be guided by the lab technician, but because of the numbers, make sure you put more effort on your site so that you can come out of this course with something. All right, good. It's a good connection, but I'm still hoping we should be able to hit 100 because this is for the whole group. That's why I made it from 7 to 8. This is not for group A or C. So this is for the whole group. So tell even the group B to join. We are going to edit at 8 so that they can attend the other class. Then when we come to the physical lectures, we are going to see how we go forward. All right, I've shared my details there and also my office. This next to the Dean's office, for those who know the School of Civil Engineering, I think by now you should know it. Just adjacent to that is the room I'm using, though I might be moving maybe in a short while to the upper, maybe second floor. But for now, you can get me there. My contacts are there. Usually, I prefer emails, not text, because that's my personal number, right? But in case of anything, then through your class reps, then you can communicate to me through that number, WhatsApp or text. The purpose of this course is to understand about concrete, right? And the test, the properties, how to handle it, how to ascertain the quality. And also we're going to learn about or to get the knowledge on masonry and the various tests. Masonry now, these are like the building stones, the masonry buildings. Of course, we're going to learn this terminology as we go by. This is the course outline as outlined in your, or as given in your, what we call the curriculum. And I don't know whether you have the hard copy of this. You should have it. Maybe you can get it from the department. Unfortunately, this content is old, 1997 version. So I've just placed it the way it is, and I'm saying this unstructured. But because I'm lucky and you guys are lucky, I'm the one spearheading the review of the curriculum. I'm giving you a sneak preview of what we are proposing to be the new course content. So this is the one I'm calling structured. As you can see here, it gives you in a systematic manner how we are going to be handling this course, so that at one point you know that you have tackled of, you have learned about this material. Of course, before you make concrete, there are the ingredients. Concrete is made of cement or the binder. Let's use the word binder because cement is just one of the binder to hold together the aggregates. Now the aggregates, this is what we call the sand or the ballast, but technically when we come to now engineering terms, we talk of the fine aggregates and the coarse aggregates. We are going to see about that. And then we can be able now to make concrete once we understand the individual constituents or the aggregates, how to design different mixes. And now later on, because we are designing concrete so that we can build a structure, and basically now we are talking of either a building, a bridge, a dam. Then for a building, there is a part now we need to learn about the building stone. And this is the part we are talking about the masonry. So later on, when we come to civil engineering materials too, that will be now timber, steel, and plastics. So civil engineering materials one is concrete and masonry. All right. So in case of any query, just as you are typing the section that you're typing your name and the registration number, you can also use it to ask any query, to ask any concern. And then later on, we can also have a one-on-one interaction on WhatsApp here, or I mean on Zoom. What is expected of you as you finish this course is that you should be able to know the various methods of cement manufacture, so that you don't just be talking of Baburi cement, Siba cement, but you'll be able to know how it's produced, to know the chemistry, what happens. You know, I had a very interesting question in the field this week. A guy was asking me, like, he's not in civil engineering or in structural engineering, but he was asking a very, very critical question. He was asking, we pour water on, or what you call curing, we pour water on concrete. Until when or why do we stop at this stage? And I had to explain to him that the binding of cement is not just like the way we talk of mud or soil. It's not something physical. It's a chemical reaction that requires water. And then I had to explain, of course, in a layman's language, that the chemical reaction will go up to a certain point, beyond which, if you have not provided the required water for curing, then nothing much will happen because you have already lost the essence of cement. So you need to understand the various cement manufacture and the chemistry, the concrete ingredient, and the various tests that you can do to ascertain the quality, how to carry out concrete mix design, right? And then you understand the various stages of concrete production, some of the tests that are relevant for at each stage. Because you see, concrete is not like steel. You know, steel, like steel bridge, right? I'm not talking about reinforcing steel. I'm talking about like steel beams, right? Like the way you see on Decker or those steel structures. That is prefabricated in a controlled environment in the yard, in the factory. But for concrete, everything is in situ. Of course, we have the in situ, the ready-made concrete mix, like we have this alliance concrete, which prepare concrete in a controlled environment, and then they bring it on site. But most of the construction project that you are going to be engaged in, you find that concrete is created on site. And in so doing, there are so many, there are many chances of errors coming in as much as you have done your mix proportioning, but from the preparation of the aggregates, that is the sand and the ballast, to the ascertaining the quality of the cement that comes on site, because we know not all companies are standardized. Some of them, you may think that you are using cement of this class, but if you do a test, you find that it's slightly lower, right? Because these are commercial establishments. That's why we have these control tests. That's why we are saying at each of every stage of concrete production, you need to understand the relevant tests. When you get cement, for example, if for a bigger project, of course, for a small project, we just go buy cement from a hardware, and we assume that it is it meets the quality or the standard that is indicated on the maybe on the cover, on the bag of that cement. But for big projects like these, for a dam, you have to go to the lab, conduct tests on that cement to see whether like the setting time, the strength, whether it fulfills or it achieves the requirement or the target strength. Then you go, you take your aggregate, you take them to the lab, you conduct tests on them to see whether they are good quality aggregates. Then once you do the mixing, even the water that you're using, sometimes we check for mineral. For example, when you're in Mombasa, you cannot just go and get the seawater and then use it for concrete production. So you see, there are various tests at each stage, and those are the tests that you're going to learn. Quality tests at each stage of concrete production. And then, of course, you're going to understand or to learn about the different types of concrete, the effect of admixtures. I've highlighted that because you're going to learn. At this stage, you might not know what are admixtures, but we are going to learn or to know what they are and why they are important and when do we need to use them. And then finally, as you add this course, you should know, understand the various types of masonry and mortar, their properties, factors affecting them, and the quality for each. So this course will be taught in terms of lecture, what we are calling physical and online. But this one, we are yet to conclude effectively because one, I posted what we call a poll, and a number of you have casted their poll there, but I needed to get at least 100 plus. But so far at this stage, provisional results shows that people are interested in blended learning. Blended learning is one that have got high percentage. We have physical lectures coming number 2 and purely online lectures number 3. So that means we can't have purely online lectures. But then I also wanted to understand how much of this blended. So we are going to be conducting polls with time, but also make sure if you have not cast your opinion or your poll there, do so that we can have a balanced opinion. Yeah? I'm also looking at this. I'm wondering, why can't I create a poll here on? I should be able to create a poll here. I don't know why it can't. I'm going to see that about that. So this is just a tentative illustration of how we go, or structure of how we are going to do the learning, lectures, physical and online, weekly sessions. We have interactive tutorials, laboratory work. This will be guided by laboratory technician. And those who forgot the orientation, I know you had done orientation last year, but now you should become acquainted with the structures and materials lab. That is the one next to the workshops, because that is where almost, I think all tests for this course will be conducted. And as you can see, if the class labs shared already with you the materials that I shared yesterday, we have over 15, and these are the minimum tests, minimum practicals that you're going to conduct. So that should become part of your home, because the test that you're doing this second year, towards the final year when you have your project, again, you might find yourself that you are spending much of your 5th year in that lab. So we also be having other presentation, of course, or demonstration that may be deemed fit. In the meantime, if you look at your timetable, for those who have it, I wanted to share it here, but it's too big. But I'm looking at the schedule, and this time round, it seems it's a bit scattered. My understanding is that is the issue of rooms. Because I'm seeing like you are supposed to have practicals the same day and theory classes the same day. But I'm seeing like on Monday, group B is supposed to have practicals from 8 to 7 to 10, I believe. Then the other groups are supposed to have their practicals. Where is this? Their practicals on Tuesday. Group A and C are supposed to have their practicals on Tuesday. Then our classes we have on Thursday. Morning session, we are allocated the room CLB 105. I don't know how big this is because I was believing when we have physical class, group A and C can be together. And then the group B, we can be together. But as you can see, we have two allocation of physical classes. We have Thursdays, that is, my class will be on Thursdays. We can either have a session from 8, we can't have the class for the whole day for the 3 session. That's almost impossible. So either physical class 8 to 10, and then 2 to 4, right? So we can have 2 to 4. If all of them are physical, let's assume we have next week to be a physical class, then we can have group A and C joining the morning session. Then in the afternoon, we can have group B. But those who are in group C who would like to join the afternoon session, they can have, we can have part of group C and group B in the afternoon session, because I can see group B doesn't have a class in the afternoon session. Why do we have to define like this? It's because the group 105, I mean the room 105, in my own opinion, if I'm not wrong, it should not exceed a capacity of 100. And again, if a class is too large, all right, let's say like when we used to have classes in assembly hall, sometimes if I write something on the board, you might not be able to see. So classes of 100 should be adequate. So we're going to see maybe class B, we can make it class B1 and class B2, so that class B1, class C, we can make it 2 groups so that they can either be joining group A or group B in the afternoon. But we are going to see that or to plan that with your class reps. This is the course assessment. I know by now you already know the regulations, the college regulation, that the exam constitutes 70% apart from the design. The design is 50% exam. And also, I think there's a course called workshop practice, which is 100% practicals. It doesn't have an exam. But ours is a standard course. So we have 70% exam and continuous assessment as 30%, which is distributed as follows. 15% is the CAT, laboratory practicals is 10%, and assignment is 5%. So you see, to pass, although you're not just barely passing, by continuous assessment, out of that, you should be able to get over 20. Then you'd only be looking for 20 out of 17 an exam. That is for just somebody who want to get the bare minimum. But to me, I also always encourage my students and inform them that it's not much about passing. It's not just about getting that A or a B or a C, but education is what remains after the learning process is over. So if don't be so much carried away by the fact of you want to pass at all cost, but focus on understanding. Like this, most of whatever we are doing are things that you're going to explain them actually from next internal attachment. When you come to internal attachment, these are the same tests you're going to do. When you go to external attachment, if you are attached in a construction firm, basically these are the tests you're going to do. So your focus should be more on understanding the principles. And you see, in the field, maybe you'll not be taught of theory. This is the time to understand the theory, the chemistry of cement, and then how, or the rationale, the logic behind this practical, so that when you come to the field now, you are not just another technician, but you are a little bit advanced. With your degree, you'll be able to provide leadership as well as a guide in these decision-making processes. This is the list of practicals. I shared this with you already. As you can see, I'm trying to make you as digital as possible. I could have shared a document to your class rep, but then, you know, we have repositories, because I'm directing you also to be downloading journal papers from the university library. So the library doesn't give you a PDF of those papers. So you have to learn how to click links to go to websites to download and source materials and so on and so forth. So I shared the link where you will be able to download this course assessment. The link also how to download on where to download the content. And just a disclaimer is that the content that I shared, the notes, these are a bit outdated, so we shall be updating them as we go by. These are the notes that I was using in 2016, so 6 years ago. So we shall be updating them as time goes by, and that's why you need to be in class, because there are some materials that we shall be issuing in class which are not there in these notes, right? So as you can see from this table, or from what you have, there are some tests. I'm just making your work a little bit easier. Of course, I've given about 13, and one of them have got ABC. So if you have 14, 15, 16, 17, 18. So these are about 18 tests or practicals. But in terms of reporting, there are those on the remark side. You can see where I've said submit report. So these are the ones that I require you to prepare a standard laboratory report, okay, for submission. For the one that I'm saying demonstration, this one I leave it to the technician. If the technician, because when you go to the lab, you should follow the instruction by the technician. I believe by the end of this month. Of course, I'm sharing this also with the technician. So by the end of this month, and maybe class rep, you could visit after this lecture. You could visit the lab technician. I believe Mr. Juma is the one in charge of the structures and materials lab currently, and we also have Mr. Ken there, so that at least now you start getting acquainted to the lab and also arranging the schedule. Because your timetable may say this is the schedule, but then remember our structures lab is being used by a master student, by PhD student, by Pan-African University student. So the schedule shown here by the timetable, or the person who prepared the timetable, you may find like it's crashing. So be a bit flexible. Don't be rigid and go with your timetable. Say this is a timetable that we have. Listen to what the lab technician will be directing or guiding you. And again, if you want to have a smooth flow, those people know much. So don't go there and look down upon them and say that these are just technicians that I'm learning for a degree. If you want to learn much from them, because these guys are experienced, make sure you follow their instruction, follow their guide, and you're going to, enjoy your time there in the lab, as well as learn more from them, because they have a lot of knowledge in them. So submit report. Those are 1, 2, 3, 4, 5, 6. And this is why I'm saying in the course assessment, the previous one was practicals, this is assessment. But there's something I want to point out from this one, from the assessment, and I hope you can be able to, maybe let me just highlight this. I want to highlight this to you. Work in a group of 6 members. Why did I say this? There are 6 practicals there. So I expect each person to compile 1 report, okay? And it's the onus is on you to organize yourself in groups of 6, depending on how you want to work. Of course, you want to have members who you are able to relate well with. And also note that you are supposed, don't allow joyrider in your group, because the marks that will be scored for each person is distributed equally amongst the group members. Then don't make a mistake of duplicating other people's work, because we penalize every. Okay. Now, this is the same for the practicals I was showing in the previous slide, the practical work that we wanted, I was showing in the previous slide. This is a practical work. So you organize yourself in a group of 6. That's how you are going to prepare these 6 reports. Of course, the other tests if the technician says you want to see some reporting or some results from this other test that I'm saying demonstration, you have to follow that. Once you have your group from the practicals, it's the same group that you're going to move ahead with in the assignments, okay? And our assignment for this semester is just this assignment one. We may have another one, but in the meantime, let's just consider this one, where you are required to use from the test that you're going, to do concrete mix design, as we are going to see in the theory work. You need some preliminary information, prior information that is obtained from the lab test that you're going to conduct. And therefore, using the test or the values that you determined from the previous slide or from the practical work, you are now going to do this assignment. You go ahead to design a concrete mix following this method in the group of 6. Group members will agree on what class of concrete to design. But this one, I want to assign it to class reps, because I don't want all of you choosing class 20. I'll be marking basically the same report. So we want to have, let's say you are 120. So 120 in the groups of 6, that will be 20 groups. So 20 groups, and you want to design 3 classes of concrete. So I expect at least 6 groups to have class 20, 6 groups to select class 25, and 6 groups to select class 30, or 7 groups to select class 30. All right, at least that balance will be there. And then submission of this report is just a suggestion. We could submit earlier, but not later than the 14th week of the semester. Why? The 14th week is when you are going to do the exam from the 15th week. So it means if you submit after that, then you will not have time to mark, because immediately after the exam, you're only given 2 weeks to mark the exam. So you need them. If the earlier, the better. If I can be able to get them early enough. What I know is that some of these practicals, of course, like concrete mix design, to do the compressive strength test, you wait for 28 days. That's a whole month, right? So there are some results. If you start late, you might not get results by the end of the semester. So you should move with speed. Immediately after this lecture, maybe next week, you should start your practicals, but you don't just appear there. Yeah, said your class representative, let them go like this week to the lab technician, let them agree when it's a due time to start the practicals, because there are materials that need to be procured, and procurement process in government institution is another process altogether. Right. What else is remaining? Yeah, this is the references. This is a list of references that are crucial for this work. The first book, you may be able to get the first and the third in the library. It's a very crucial book, a very good book, which you'll be able to learn more about the properties of concrete. Then number 4, you can be able to download it online, Design of Normal Concrete Mixes. If you don't get it, I can share it with you, but this one is available freely. And this one you should have. I mean, you can't do concrete mix design without a guide. It's like you're saying you can't design. Of course, we have not started the proper design in civil engineering, but you realize in design, you always need a code. So the same case in design of these concrete mixes, you need a guide. This is the one. Then journals and online materials. You are privileged because during our time, we didn't used to have this. But currently, the library is offering so many journals which are free to access online. Some of these journals, you can't just access them wherever you are. Maybe you may need to use the university website, the internet. Sometimes you may need to register. But as a student, I think you have much more privilege to access these channels, which most people out there can't be able to get. Like this, you are seeing really InterScience, Springer, Cambridge journals. They are high-ranking journals, and they are a bit controlled. So you try that. The beauty or the good thing about getting information from journals is that you are getting latest information. You see, a book that was written or authored in 2005, there are changes that have come into place, as you are going to see. Actually, even your course content, which was prepared in 1987, it's not that it's bad, but after 97, there have been a shift in technology, new materials, EPS, use of fly ash, new admixtures. But during those times, they were not there. So you find like that information may not be in this textbook, but it's in journals or in new books. But new books, of course, they are expensive to acquire. So we'll be utilizing most of this latest technology from these journals. And finally, laboratory manuals, which you are going to obtain from the lab, but as well as you can be downloading them. Like if you are to do some aggregates, let's say aggregate test, and then they say they are conducted according to BSTs, then you can go ahead and search for that BS. BS is British Standard, and search for that and download, right? Okay. As I said, today was an introduction. Here is some just a note that the discussion of the laboratories tests that I've indicated here. In class, we only give a brief theoretical description so that you can understand, you can have an understanding. But the procedures are outlined in the manual. So when you go to the lab, that's when now you get the laboratory manual and the guide on how to execute these tests. So a big portion of this course will focus on understanding the major constituent of concrete, its characteristic and use, and a small portion towards the end on masonry. So since concrete is composed of many materials, we talk of normal concrete, which is consisted of cement, aggregate, and water. And that's the one that we are going to focus with. Of course, we'll be mentioning about different types of concrete. We have a high performance concrete. We have a lightweight concrete. We have maybe high strength concrete. We can have different types of concrete, but now we can't introduce everything because it's an introductory course. We can't introduce everything at the same time in this course. And because we want to understand to the core about the constituent materials, so we'll be focusing on normal concrete. Therefore, we'll be talking about the constituents of normal concrete. That is the cement, the aggregate, and water. So other special concrete, which can be produced by incorporating other ingredients, apart those used in normal concrete, will be mentioned in brief. So that's it. That's the outline that I wanted to give. Two things that I want us to agree with your class step. One is on the schedule, but we agree that the class is on Thursdays, physical, whether if online we can have another adjustment. Then number two is that we can only have 2 sessions because you can see even our venue, physical venues are 2 sessions. Then number 2 is that complete that what we call poll, so that we can have a balanced opinion. Okay, so at this juncture, if there's any question, I'm looking at the chat area to see whether there was anybody who raised any comment. Of course, I don't expect much because it's a course outline, but today we could have questions based on the structure of this course, like how we be handling this course. Of course, I wanted you today to experience the online. Our online is have been oriented today. Then what you do, if we have somebody, if you have somebody with a question that you feel you want to speak, at the end of this, usually I share the link. I have shared the link now with the class step, the Zoom link, because I'm on Zoom, so that you share it with your members. If there is anybody with a question you want to ask live, then you can do it now. If you have any concern, you can chat it in the chat section. And then we address it as we go by. All right. So that's all from my end. It was a short one about 40 minutes, because I know there's a class group B starting a class at 8. So we say we meet next week for starting of our lecture. Next week we start with the cement, and we'll be having for now we'll be having a physical class from 8 with the group A and part of group C. Okay. All right. So that's it. If you have any query, I've shared the link with your class rep. Class rep, you share the link with your group. Why we do not share it directly here is that we try to control what we call spamming. Okay. And that's why you have seen like we also have some what we call codation. Before you can chat, there was some codation that you needed to fill, so that we not just anybody. We don't want spam bot here. Joining our I'm trying to understand why I can't be able to create. I'm logged in using my account. I wanted to see whether I can create a poll, because I believe it's possible to create a poll here on this chat. Okay. I'm just looking to see whether there is any question that I can address. If not, then we call it a day. Okay. All right. Okay. That's all for now. Just looking to see whether we meet next week. Okay, Stacy, I can see yes. You have a question? Stacy? Yes, Samuel Gilo. Any question? Or you are trying the link you are trying to see where the link is working. It's working. I'm here. All right. Okay, if no question, then let me release you so that you can attend the other lecture. Mateka, any question? Faith Mwangi? You only log in if you have any question that you feel like you won't be able to express it adequately in the live chat. Okay. Then we meet next week, but we'll be communicating with your class labs in case of any change. So that's it from me. So until next week, bye-bye. So make sure you have the class note. I've already shared with the class rep. Make sure you have that link. You download the class notes and other material that you may find interesting for your work. Okay. So bye-bye.